Hi, let me tell you about another great Manning book, Build a Reasoning Model from Scratch, written by Sebastian Raschka.
How do large language models, LLMs, handle reasoning? While most LLMs are good at general instruction-following tasks, reasoning models are designed to solve more complex math or coding problems. Here, we focus on building a reasoning model from the ground up, starting with a pre-trained LLM to better understand what they can and cannot do. Reasoning in LLMs means the model can show intermediate steps before reaching an answer, a process called chain of thought or COT reasoning. This is similar to thinking out loud, rather than just giving the final answer. LLMs are first trained on large amounts of text to predict the next word in the sentence. After this, they go through extra steps, like instruction and preference tuning, to make their responses more in line with what people expect. As a result, LLMs can write text that sounds human, and even do tasks they were not directly trained to handle. Think of an LLM as a super-powered pattern matcher, not a true thinker. It doesn't actually reason or understand things the way people do. Instead, they predict the most statistically probable next words, based on patterns they've learned from vast amounts of text. For instance, an LLM knows Berlin is the capital of Germany because it has seen that connection repeatedly. LLMs don't actually reason with logic. Instead, they imitate it by spotting patterns. If an LLM sees a certain kind of reasoning problem over and over in its training data, it gets good at handling similar problems. But if it runs into a brand new or tricky logic puzzle it hasn't seen before, it will likely struggle. To increase the model's so-called reasoning, LLMs use three main approaches. Inference time compute scaling, using more computing power to think a problem through. Reinforcement learning, getting feedback to improve their reasoning strategies over time. Supervised fine-tuning and model distillation, transferring the reasoning skills of a huge model to a smaller one. Building these new reasoning models helps us understand exactly how they work and what their limitations are. While they're great at complex tasks, like solving hard puzzles or advanced coding problems, they aren't necessary for simple things, such as translating a sentence. In fact, using them for everything can be very expensive because they need more computing power and often create longer answers. Understanding these trade-offs is crucial. We'll guide you through building a reasoning model step by step. First, you'll load a standard, pre-trained LLM. You'll then learn how to test its current reasoning abilities, so you can measure your progress. Next, you'll use specific methods to improve the model's responses and reasoning without retraining it. Finally, you'll use training methods to turn a basic LLM into a dedicated reasoning model.
Get this book at Manning.com